next question is that you have a small block like this. They've even given you the dimensions. 4 decimeters by 2 decimeters by 2 decimeters. And then you triple all of the edges. So you're increasing it in a scale of 3 to 1. And the question is, what will be the increase factor, I think. I think it only asks for that. How many times as large? So what's the, how many times as large will the volume be? How many times larger volume and how many times larger surface area? So they don't want an actual number. They only want to know how many times. So we actually really don't need to do any calculation here of the volume and the surface area at all. Because we know that the volume will be the scale factor cubed, the length times the breadth times the height, larger. Whereas the surface area will be the scale factor, which is 3 squared, larger. So the volume will be 27 times larger. And the surface area will be 9 times larger. And that was actually all you needed to do for that question. You could calculate it, absolutely, but you didn't need to. You know the scale factor if each of the dimensions increases by a factor of 3. The volume is going to be 3 times 3 times 3 larger, 27 times larger. The surface area is going to be 3 times 3 larger, 9 times larger. Scale factors. You can, if you would like to, work it all out, if you love it. But you don't actually need to. Then we have a question where we have a cube that is again 1 centimeters cubed, and you have 64 of them. So we're going back to being little kids again, and we get to build with 64 1 centimeter cubed blocks. And we have to make 2 different types of blocks. One with smallest possible surface area, and one with the largest possible surface area. Well, we know, we'll start with the largest because that's the easiest one. The largest we're going to get is going to be 1 cube placed after itself all the way along till we had 64 of them. So if we were to have 1 centimeter cube like this, and then have them all in a really, 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 really long line, I'm going to break it in the middle here, till we've got all 64 of them in a row. Okay? So you'd have 64 cubes that would be 1 centimeter by 1 centimeter. That's going to give us the largest possible surface area, putting them in a really, really long row. Now we have to think that, okay, we have 64 centimeters cubed. What are the different factors we could have of 64? Well, the volume of this one would be 64 times 1 times 1. Let's think of different ways we can get 64. We could get 64 by 32 by 2 by 1. We could also get 64 by 16 by 4 by 1. But 16. No, that 16 is 4 squared. 4 by 4 by 4 instead is a good way of getting 64. 16 is 4 fours. Multiplied by 4 will give us 64. So now we found that and we know in order to have the minimum possible surface area, we want as cube-like as possible. We've got an exact cube if we use 4 times 4 times 4. So we break down our factors of 64 into different combinations. So there are our 2 possibilities. This one will give us the largest possible surface area. This one is a proper cube, it will give us the smallest possible surface area. So the largest possible surface area would be, we'd have 64 times 1. That will be this one face here. And we're going to have 4 of those. So to calculate the actual surface area, we need the area of each of the faces. We'll have 4 faces that are 64 times 1 centimetre. And we're going to have 2 faces, the one at the front and the one at the very back, that are just going to be 1 centimetre by 1 centimetre. I should put in the units there, sorry, centimetre by 1 centimetre. So we're going to have 64, double that, we get 128, double 128, we get 256 centimetres squared, plus 2 centimetres squared. So the surface area, the largest surface area we can get with these blocks would be 258 centimetres squared, whereas the smallest surface area would be the area of one face, which we know is 4 centimetres times 4 centimetres, times 6. We have 6 faces. So we have 16 times 6, which will be 6 sixes are 36, carry 3, 6 ones are 6, plus 3, 9. 96 centimetres squared. You can see there's an enormous difference between the cube that only has 96 centimetres squared and the largest possible surface area using exactly the same number of blocks as 258 centimetres squared.
Wendy?
Yep.
Do you get the question wrong if you forget?
We'll take the points afterwards. Then the very last question is show that the volume of A is twice the volume of B. And they've given us some dimensions, and you guys were asking me what value of pi we should use. You don't actually need any value of pi because pi is going to cancel here. Keep everything in terms of pi, and pi will cancel when you divide volume A by volume B. So we have that this one has a diameter of 20 centimetres and a height of 10. And the second one has a diameter of 10 centimetres and a height of 20 centimetres. So the first thing we do is get rid of diameter, because we know that we're using volume, and the formula for volume is pi r squared times h. I haven't defined r here, so let's do that. Okay, so let's call A cylinder A. So the volume of cylinder A, radius is 10 centimetres, radius is 5 centimetres. So we need pi times 10 squared, the radius squared, times height, 10. So here it's nice and easy, we're going to get 100 times 10, so we're going to get 1,000 pi centimetres cubed. That's going to be the volume of cylinder A. Let's look at the volume of cylinder B then, same formula, pi r b squared times h b. Here we've got A, the heights of A. Call it HA here, so we differentiate between cylinder A and cylinder B. So here, what we want is pi, the radius here is 5, so we've got 5 squared times the height, which is 20. 5 squared is 25. 25 times 20. 25 times 2 is 50. So 25 times 20 is 500. 500 pi. So here we have 1,000 pi, here we have 500 pi. Prove that cylinder A has twice the volume of cylinder B. Well, then we want to divide volume of cylinder A divided by volume of cylinder B. So we get 1,000 pi divided by 500 pi. The pi's cancel, we get 1,000 over 500, which is 2. So therefore we've proved that cylinder A is twice the volume of cylinder B.